So now that we've calculated the concentrations and we have checked that the files are okay, we now have to set the different variables and give the information about the experiment. So that happens in the variables tab. So the first thing that we need to type in is the title of the experiment. And in your case, we can say that this is, let's say, Glenn Burley's compound with, it was probably Carthymus DNA, was it? Yeah. Carthymus DNA. Your buffer was 25 millimolar MOS. pH 7. And how much salt was there? 50 millimolar sodium chloride. Okay, 50 millimolar sodium chloride. And was there any EDTA? And 1 millimolar EDTA then. I was typing commas, but because of the way that this gets imported into Excel, it is better not to use commas here. It doesn't matter if you do, but it can be nicer. Now, the file name is 10, 12, 14 again. The temperature was 25 degrees, and there were 38 injections. And the concentrations have already copied. When you type the concentrations here, they also went to the variables tab already. So now what you see here, these are numbers that came from previous experiments. So what I can do to start with is I'll set everything to nothing. Let's just check. Nothing is to be optimized. You don't have to do this, but now just to do a very clean analysis, I'll set everything to 0. So if we look at your data, it looked as if there was maybe 1 or 2 equilibria in the beginning, but what we'll do first is we'll just assume that there is one binding event, and that one binding event is followed by dilution. And we're going to assume that the dilution, or we have to assume that the dilution is exactly the same as in the dilution experiment. So what we know is that we have a K of aggregation and a delta H of aggregation, and we're going to take the numbers from here. So K aggregation, we take the best number that we have, which comes from your fit. So there you go. And we're not going to click the box optimize here because we don't want this number to change. This is the number that we're going to use, and it's going to be fixed. Similarly, we have we have the enthalpy of self-aggregation, which is also a number that we're going to take, but we're not going to optimize it. So now the other numbers that we need to give is the binding constant. The binding constant, we're simply going to guess that it is approximately 1 to the power 5. So this is equilibrium A1. The enthalpy of the interaction, it looks as if, well, we see that it is exothermic, so we're going to say it is about minus 5,000, looking at your graph. And your stoichiometry, well, the stoichiometry here is about 0.5, but I'm simply going to say 1. It doesn't matter. It doesn't matter too much. Now I want these parameters to be optimized. So I press optimize. I also press avoid 0. And there's a reason for that, because when you analyze data, if one of the parameters goes really close to 0, for example, if the binding constant goes very close to 0, then the enthalpy can be whatever it wants, and it doesn't really change because nothing is binding anyway. And this can cause problems with the way that we do the analysis. So we have avoid 0 in here. Now there's one more parameter that we need to include, and and that is the dilution. And I'm going to set that to 500 because I think at the end of your titration the numbers are a little bit positive. But this number should normally be small. It should be less than plus 5,000 and more than minus 1,000. But it is variable. So now what we have done is we have 4 optimizable variables which are optimized and avoid 0, and we have 2 parameters that we're not going to change at all. There's one other important thing, and that is if you set a parameter here, never make it if you set a parameter to 0 here, never make it optimizable because it also causes trouble in the fit. So we've defined absolutely everything that we need to do for the initial parameters. We now click the write button, done, and if we go to the folder here, what we see is that the variable file has been written. And if we open that, we basically see that it contains all the information that we have just been typing in. So we can close this, and that concludes this part of the process.